All right, welcome to track 2. Please join me in welcoming to the stage Katie Knowles from Datadog with her lightning talk, I Spy, Rethinking Entra ID Research for New Paths to Global Admin. I would guess the SP has something to do with service principles. This talk is sponsored by Tracebit. Take it away, Katie.
Good morning. Thank you all for joining me. I know it was a fantastic night last night, and I appreciate you waking up. Welcome to I Spy, Rethinking Entra ID Research, and all the stuff Andrew said. A little about me. My name is Katie Knowles. I'm a cloud security researcher with Datadog, where I primarily focus on Azure security research. And around this time last year, I had just started in my research role. So I was wondering what words of advice the fantastic CloudSec community had for me on how to do my own projects. At which point, Dan Gerlach provided the following fantastic advice. Now granted, he was dressed as a slice of noob cake to encourage us that research did not need to be intimidating, and he did say I could use this image of him again. And I figured I'd use his approach to structure some of my own projects this year. I had a couple different approaches and topics I wanted to learn about, but especially for getting some foundation on topics like Entra's application model, I really wanted to try and use this approach where you didn't necessarily need something new. You can build on what already exists. So today, we're going to talk about that journey. We're going to go over Entra ID's application model and how that relates to service principal hijacking. There's so much to go through, so I'm just going to jump in. We'll start out with the history of service principal hijacking, and then we'll get into the details in a bit. But what you need to know is that this has been a thing since 2019. Dirk-Jan Malema published a blog post about how Microsoft's first-party applications could be used for privilege escalation and persistence. He originally reported this to MSRC, and they said, oh yeah, we totally fixed that. And then he went and checked, and they hadn't. So he then said, are you sure? And they said, oh no, actually that's by design. You need to be able to assign a credential to the local identity of the app, just for usability sometimes. I don't know, yeah, feel free to publish it. In 2020, there was some threat actor activity, not directly related to first-party app takeover, but general applications. We'll talk more about how that works in a sec, but what you need to know is threat actors were starting to pay attention. The Azure team also released their Storm Spotter tool, which helped a little bit more with mapping permissions that service principals had to understand the risk that certain applications might impose. We had a talk at Forward CloudSec from Emilian Chebuk and Christian Filippov highlighting the risk of service principals again, and the fact that there were over 300 first-party apps in a default tenant, so there was a lot to choose from if you wanted to take over Microsoft applications. And sure enough, in 2022, threat actors started doing it too. You might think that this would have influenced the app instance property lock being added, and I'm not sure, but I think so. Basically, this setting made it so that if a developer flipped this switch on their application registration, you would no longer be able to add a credential to the local identities for that app. So it protected the local privesc scenario that we'll be talking about today. But Microsoft didn't seem to implement that for all of their applications, as seen by some research last year from Eric Woodruff, where he found further Microsoft first-party apps where that 300 plus we're talking about, that shrunk, but there were still a few that allowed privilege escalation to global admins, sometimes with undocumented permissions. So we went from this being reported and Microsoft saying, we don't think this is an issue, to them saying, we still don't think this is a material flaw, we don't see this as a problem, but after all of this, we can see how you might think it's a problem, so we'll start to fix it. You might think, based on everything we've talked about, that this is just completely fixed. It's no longer an issue, but when it was initially reported, we also saw that they said it was fixed when it wasn't, right? Are there any more gaps we can find here? I figured I'd test that out. Personally, this application model had been frustrating me for years, and this was a great excuse to dive in. With an Entra ID, this is the background we'll need to go forward, an application is composed of two objects. One is the app registration, and the other is the service principal. It's safe to think of the app registration as the definition of its app, who made it, what it does, what permissions it needs in order to function. And the identity is what makes it go. It's the part that takes actions on that application's behalf. If I create a user management application and I decide to consume it, then I'll have a service principal and an app registration in my Entra tenant. I created the app and I'm using the app. If you then decide you want to install that user management app in the same way to your environment, you'll then have a service principal added to your consuming tenant and be able to give it the same permissions that my application has in order to use it in your environment. Based on what we just said, you might think that the two are just completely linked. All their properties must be the same, right? We said definition and identity, but that is also not the case. Some properties are directly inherited. For example, the application ID links these two objects completely. Other properties are derived. So on the app registration, you can define what permissions an app needs to function, but then an administrator needs to consent to them to add them into that service principal. So an example would be that the app role assignments or the application permissions, these are kind of used like a service account type permission. An app can use them without user interaction. And then the OAuth 2 permission grants, or the delegated permissions that are granted to the app, allow that app to take actions on behalf of a user. So that process of an admin or a user consenting to different permissions will then add those into the identity, but they're not the same exact thing, right? Other properties have the same name, but they're totally different. Something that really shocked me about this is that key credentials and password credentials are properties that can be set in either place, but they do not go back and forth at all. They don't synchronize in any way. So if a credential is assigned in either of those properties on either of those identities, you can become the application. Visually, it looks a bit like this. If I'm the app owner and I add a credential to the app registration, so like a secret or a certificate, then I can authenticate as that application anywhere it's been installed, which should really make you think about how much you trust my user management app and me, and any app that you add to your environment, right? On the other hand, if you want to use that application and kind of impersonate it in your local environment, I think this was added for debug purposes originally, you can add a credential to the local service principal, that local identity of the app, and you can also be that user management app within your environment if you have the right permissions. This is starting to sound a little attackery at this point, right? So anybody with the application admin, cloud app admin role, or owner over an application will be able to add credentials in this way. The application read-write all permission will also grant the same thing if you're using like a compromised application. So in this illustration, we're seeing that an attacker with one of these roles in the publishing tenant can add a credential to that application and then be that application in any environment where the app was added. On the other hand, if they have the same permission in an environment where the app was already added, the consuming tenant, they can still do some pretty interesting stuff, right? We're talking about a highly privileged app here. So if they can add a credential onto that, you might not suspect the app as much as attacker 123's account. So where this gets extra hairy, you can't see the credentials on service principals the way that you can for app registrations in the Entra portal. So it's very sneaky. We're taking actions as applications, not users. And this still includes some Microsoft first-party applications that we can impersonate. What do I mean about first-party? I keep saying that thing. What does it mean? And I want you to take a step back here and think about when you interact with the Azure portal. To you, it looks like you are using one web application. The reality is you're using a complete mesh of services linked together by these applications we just talked about. Microsoft's first-party apps are installed by default. You might have your own applications users use to create their own services, and you might install third-party apps as well to provide service. So it's not as clean a web app as you might think it is. And this is where my adventure starts. I wanted to learn more about applications so I could give you the explanation you just heard. And I also wanted to understand service principal hijacking a lot more in depth. I didn't have much time when I started this project, so I wanted to automate in little steps over the weeks that I had, and I wanted to work directly with Microsoft Graph's APIs. The reason for this is that it's way easier to do a lot of this with PowerShell or the Azure CLI tools, but I wanted to understand the objects as closely as I could, as close to the bare metal, right? I wanted to see what was on them. I started out by trying to hijack all of Microsoft's service principals in my test tenant with a secret, which turned out to be a post request to the add password endpoint on the service principal. All I needed to do was give a display name, and it would say, okay, sure, here's your secret. Now you can authenticate as that app locally. I thought that I could then take the app role assignments off the service principal's endpoint properties, to get all the app roles. This works for local apps, but not Microsoft's first-party applications. Unfortunately, those come back blank. They don't really populate when the applications are added to your environment. So I was going to need some tokens. Now I've added a secret, I need to test I can actually authenticate as that service principal. By supplying the secret that I had just added, that I wanted a graph token in the Microsoft login services, along with the application ID using what's called the client credentials flow, I would get back a JWT. Decoding that would lead to the roles that were assigned to that application. So the Microsoft Graph permission scopes, basically. You can also see in the WID's parameter down there, the Entra ID roles that are assigned to that identity. So you can see here we have the app admin, just a good reminder that you can sometimes see a little bit more than you expect to in those GUIDs. I got a lot of errors back from this. The primary one that I saw was that secrets wouldn't work for this application, and you should try a certificate instead. These other ones basically just indicated that I didn't have permissions, or the app was something I might not be able to add credentials to. Maybe it was legacy, something like that. So I was gonna need to add certificates, right? At this point, I'd tried to add a secret to every application in my default tenant. I got a few that came back that said, hey, add a certificate instead. So I thought that would be using the add key endpoint on the service principal. It turned out, in order to use that, you need to prove you already had a certificate. Obviously, I'm not running around with certificates that allow me to authenticate as Microsoft first-party apps. So I kept reading, and they actually said, don't worry about that. If you don't have a certificate to authenticate this app, just directly modify the service principal object. It's all good. So this ended up being a patch request with the base64 encoded cert that I wanted to use to authenticate. Getting tokens in this way turned out to be a little more complicated. Not bad once you figured it out, but we basically needed to attest that we had the certificate to authenticate as that application. So I had to create my own JWT with the certificate thumbprint, various properties saying, hey, this is a valid token, I am the application, I have the certificate you trust to auth as this app, and then exchange that token for one from Entra ID. That new token is the same one we were talking about before that decoded and had all those scopes we know and love. So here you can see an example of an application that I was still able to backdoor with a certificate for authentication. At this point, we'll take a really quick look at how that looks. The script you're gonna see me running just does all of the things that we talked about, and it's a very dirty script, so you probably don't want it. The tokens that you see here are also long since expired, but we've got a token as a service principal with the Cloud Application Administrator role assigned. We're gonna use that token along with a certificate that we want to be trusted to auth as that app, and just the tenant ID as well. And once we run that, what it's going to do is add the certificate, generate that token that we're then going to exchange with Microsoft's authentication services to get a new token as the identity. When we decode that token we got back, we can see that we now have access as the Office 365 Exchange Online application. So we can now take actions as this app, we can look like them in logging, and we have access to all those interesting roles down below as well. Excuse me, that's what I get for making a slide like that. Not all of the scopes that came back were interesting, but one in particular allowed me to add, verify, and remove domains, the domain read-write-all permission. This wasn't related to Microsoft Graph attacks that I'd seen, but it made me think of another attack that I'd seen a while ago, and it led to some more adventures. In 2018, Dr. Nestori Cinema published support in Azure AD internals to add a federated domain backdoor using the Azure Active Directory graph. Now, obviously, that's not the API we're using today. It's not the permissions we have, but you can take the same actions through that API. In 2020, attackers started doing this too, and the SolarWinds attack, there were cases of SAML tokens being forged using trusted certificates for these domains. I should mention these domains were originally set up to create federated access with ADFS between that and Entra ID to trust the authentication there. I don't have time to talk about all of the different endpoints for this one, but I do have a demo to show you. So at this point, we've got that token as the Office 365 Exchange Online service principal, right? We're going to use that to add an external tenant, or excuse me, an external domain that we've registered as the attacker, 40th-coffee.net, which looks similar to the original tenant, but it's not. We will add that domain in and then get a DNS verification record just to verify that we own that domain, which doesn't really matter to us, we're the attackers. We'll just slap it into our DNS records and then request that Entra ID verify that domain's been added. Once it's been added and we've verified we own it, we can create a federation configuration. This is us adding another certificate that we want to be trusted to issue SAML tokens for any synchronized users in the tenant. At this point, we should be able, once it's added as the federated domain with our certificate, we don't actually need the domain at all. We can just use that certificate to create our own SAML tokens as users we want to target. And we'll see that the actions here are logged as that service principal, just showing that we have access to it. I'm not going to try to skip that, but after this, we'll see the actual targeting of a user. So every user that's synchronized within Entra Active Directory, or Entra ID to Active Directory, I should say, has an immutable ID property. It's the base64 encoded GUID of their on-prem ID usually. And this links the two together. The words here are really small, but what you would see if you squint is that we're using that token as the application to fetch the on-premises immutable ID property of a user we want to target, in this case, a global admin. Once we have that property, that's the identifier we need to put in our SAML token. So we're going to use AAD internals at this point to forge the SAML token. We've got the identity of a user we want to target, right, that we just fetched. We've got the certificate that's trusted to issue SAML tokens on behalf of the tenant. And then we're going to say, you know what, why don't we bypass MFA too? Because MFA claims are trusted for this external domain we've added. This will then forge that SAML token, provide it to the login services Microsoft has, and exchange it for a token that we can use in Entra as global admin. So we've essentially gone from no access as global admin to attesting that we're global admin against Entra from a different system, and then using that to navigate within Microsoft's web services. Because of the way that single sign-on is neatly built into this experience, we now have access to M365, Azure portal, all those good things. So just to recap that from a diagram perspective, we added a domain that could be trusted, we added a certificate we wanted to be trusted, and then we found the user's on-premises ID that we wanted to target and used it to forge that SAML token. We could then become really any synchronized user in the tenant, so anyone with an on-premises identity that's being synchronized into Entra ID. At this point, I thought I had a really cool finding on my hands, right? We just went from application administrator to global admin using one of Microsoft's own applications. This is something they didn't seem as hot on anymore after recent research. Unfortunately, they came back and pointed out something I should have seen from the start, which is, hey, Katie, cool tests, but you were doing this all as a service principal. Can you do this as a user with application admin? It's common to assign Entra ID roles to users primarily, though you might see it sometimes that it's assigned to a service principal. And sure enough, when I tried to do this as a user, I couldn't get it to work. In my mind, there wasn't any big difference between how an Entra ID role would be processed for an application identity versus user. We're not talking about app permissions here, we're talking about Entra roles. I was banging my head against a wall until Eric released some more research on this and mentioned that after some of the work he had done with MSRC, they mentioned that only global admins can assign credentials to that Office 365 Exchange Online service principal now. So if I tested it with global admin and a user role, it worked. If I tested it with a service principal, with app admin, for some reason it worked, but the user with app admin couldn't do it. Just a strange little glitch here. So we clarified this finding with MSRC. They unfortunately came back and said that due to the fact that this was assigned to a service principal, they weren't really interested in fixing it. It's a bit of an edge case, but still a really fascinating finding, for me at least, and I hope the journey has taught you a bit about applications. If you're interested in building your own research or doing your own research building off others, I'd say take it patiently, and how you think through the problem is the entire point of research, right? We're trying to be as hyper-specific about under what circumstances is something possible, and in wording it that way, does risk naturally fall out of it? Does this sound like something that should be happening the way it is? Definitely phone a friend if you get stuck. I've done that so many times on this research, and try not to get salty if people don't see the risk the way you see it. If you want to get started on service principal research, come find me and chat about these topics. They're all really cool. You've probably heard about some of them already yesterday or today. And aside from that, thank you so much for your time.
All right, we have time for just a couple questions, maybe two, and then we got to change over the room. All the way in the back here.
Thanks for the research. As a Microsoft expert, I would call you Microsoft expert, do you think it's expected to escalate from app admin to global admin? Is that escalation path expected? And is there any mitigations possible that Microsoft could implement or end users could implement?
Absolutely. Thank you for asking that. I think that question is the core of this talk, right? The conversation around escalating from app admin to global admin has been a changing one. Microsoft's documents still attest that this is by design, though it seems like they're doing things to fix it in the background, right? So hopefully that conversation continues to move that you shouldn't be able to do this. If you do have your own applications that you offer, setting that app instance property lock will prevent this kind of attack for anyone consuming your application. So I definitely recommend having that setting enabled. I think it's by default now, but it's always good to check.
All right, one more question, all the way in the front.
Thank you. Great talk. So has Microsoft restricted most first-party applications from this attack? Like only global administrators can now assign credentials to those?
So a couple of different points there. One is that for just those couple of, I think it's the SharePoint and the Exchange ones, only global admin can assign creds. For the vast majority of Microsoft first-party apps at this point, you can't assign creds to them locally at all. So I tried this against like 500 apps. And the ones that you saw in that list were like the 5 that came back for my default tenant.
Gotcha.
Others may exist, but yeah, they've definitely gotten better.
Okay, awesome. Thank you.
There'll be more details in the blog we'll be putting out in a couple weeks too, for anyone curious.
All right, we're going to wrap here, but before we do, what's one piece of advice you could give folks, Katie, that want to kind of poke at the boundaries around transitive trust like this? Like if they want to get started doing similar types of research?
Yeah, I think understanding the boundaries of how things are defined in different systems is probably the core of it. But also, if you don't think you're qualified, don't worry about that at all. Thinking through it really hard and taking good notes is usually what I do. I don't identify as like a natural hacker type, but I still have a lot of fun.
All right, give her one more hand, and thanks everybody for being here.